Hi, everybody. Welcome to this special CUBE conversation. My name is Dave Vellante. Really pleased to have Juan Loaiza, and he is the Executive Vice President of Database Technologies at Oracle. Juan, good to see you again.
It's great to see you again. It's always fun.
Last time we got together was May at the New York Stock Exchange. It seems like just a couple of weeks ago. And of course, a lot has changed since then. I remember at the time you were on your cloud tour. Of course, now we're on the AI tour, aren't we?
Absolutely. It's all AI all the time.
Yeah, so you guys talked about AI changing everything. That was sort of the theme of Larry's keynote. And then you did a extremely deep dive on a number of topics that we're going to touch on today, coming off of AI World in Vegas. I couldn't make it, but we had a team there. What was the buzz like? What were customers saying? I really liked, and I want to dig into this, how you positioned AI database, the lake house, and we're going to get into it all, but what was the customer reaction and the buzz like?
Yeah, it's tremendous. I mean, AI is a very hot topic, and Oracle's now kind of in the center of AI. And for database, we launched a whole lot of AI technology. So the buzz was amazing, and everyone was really interested and excited, and I mean, visibly interested. So it was great.
What impressed me the most, Juan, and I wonder if you could address this, is, we're so used to this industry in these big, giant migrations. But my understanding is if you're on 23 AI, you just are going to be basically seamlessly upgraded to 26 AI. So it sounded like a very facile migration. In addition, if you're not there, if you're on 19C, a lot of the benefits that you've included in 26 AI are going to actually accrue to those 19C customers. Can you just sort of explain sort of where we are today in terms of the ease of migration to these new platforms?
Yeah, so we launched kind of a new major version of our database called AI Database 26 AI, 26 because we're launching it in 2026, essentially. It's almost there. And yeah, if you're already on our 23 AI version, you just get it. When you apply your kind of quarterly patch, you're just going to become 26 AI. It's a super easy migration because we're basically just layering AI on top. We're not re-architecting the core, underneath of the database, which is what people worry about. We're layering AI on top. And for 19C customers, a lot of what we're doing is basically tools on top of the database. And so 19C customers will get a lot of that also. And a lot of the value is just using AI on top of the database, in addition to AI inside the database.
Now, you also made the point that you're calling this AI database. It's not just a marketing term, is what you emphasized. And I want you to talk to that because you specifically talked about key AI fundamental technologies, LLMs, vectors, automated RAG, and then, of course, the ability to search, similar objects, essentially, as opposed to just finding the objects, but finding similar objects. These are all sort of new AI enhancements, and I want you to maybe discuss some of those and why it's not just a marketing term, why it's fundamentally different.
Yeah, so there's a lot there to talk about, but the big thing is we've made a giant effort to build AI across the entire database platform. So everything from building what's called AI vectors into the core of the database, that transactions, disaster recovery, everything integrated with everything, and then AI across all the breadth of the database, everything from the way you create tables and schemas to the way you move data, to the way you run queries, combinations of queries between vectors and database, and then all the way up into the application layer also, like how we develop applications. We put a lot of new technologies for AI in there, and then moving on all the way into Lakehouse also, and running AI queries against existing database. So we have over 100 projects in AI in this release of the Oracle database. And so we're just putting AI all over the place. It is kind of a fresh new database that's been completely infused with AI, not just in one place, but throughout the entire stack. Everything about the database we've infused AI with.
And if I understand it correctly, all the mission critical stuff that remember, of course, you used to have mission critical in your title, but all that stuff that you've been building for decades migrates into 26 AI. So I don't have to worry about that. The governance, the security, all that framework is automatically built in. Is that correct?
Yeah, so that's part of what we talk about, which is we're architecting AI into the database. And so that means that everything that we've done from scaling transactions, disaster recovery, security, everything that Oracle's built for the last 40 plus years immediately applies to AI, because AI is just part of the database. It's not something that sits outside the database. It's inside the database. So we're bringing AI to the data in the database, and all those mission critical features will run against the AI. So you can take AI, you can take that database and apply it, apply the upgrade, and you're set to go. You have in your mission critical database.
So the other thing that I noticed is you talked about, and this might have been in a different talk, I think it was, you talked about the ability to deal with, different data types, relational, document, spatial, text, streaming, graph, traditional data warehouses, geographically distributed. I think IoT was in there, blockchain, all these different data types that you're now bringing together sort of under one framework. So I wonder if you could talk to that and then address, like, what can I do today that I couldn't do previously with all that data?
Yeah, so that's one of our big value props at Oracle. Number one is, all the mission critical scaling, availability, security. And also we handle all the different data types and workloads. So this is something that we've worked on for decades, the ability to handle not just relational, but documents and, like you mentioned, spatial and graph and everything else, and the different kinds of workloads like data warehousing, OLTP, IoT, everything. And then we've integrated AI into all that. So you get AI for all those things at the same time. So you don't have to choose and pick or have, one kind of AI over here, a different kind of AI for documents, a different kind of AI for something else. It is the same AI that works across all the different data types and all the different workloads, which is a big deal because part of what's happening is every product is bringing AI into their product, and they all have different approaches to AI. So if you're a customer and you have different workloads, different data types, you might have a dozen different kinds of AI that are suddenly coming into your company, which is just going to increase the complexity of doing everything. I got to learn AI for this guy, I got to learn AI for that guy, I got to learn AI for somebody else. So yeah, it makes the world dramatically simpler if you just have one AI technology, one AI architecture, and it's architected into the data. You don't really have to do a whole lot. I mean, that's the other thing that's interesting, because we architected AI into the database. It's super simple to use and super simple to adopt. So for example, to do an AI search, you just add one line of SQL to your data, one line to your SQL statements. That's all you got to do. We take care of everything else.
So are there any use cases that stand out? I mean, obviously the traditional use cases get smarter, whether it's fraud detection or, I've already seen recommendation engines start to get better. I'm very hopeful. Larry talked about this in his keynote around healthcare and cures for diseases and support for, biopharma, et cetera. But are there any that stand out, at least in these early days of AI to you?
Yeah, customers are using AI for everything. A lot of things I never imagined possible, things like genomic, matching, a lot of fraud. I would say probably the biggest thing initially is natural language. So the ability to do things with natural language and using natural language that were never possible before. So matching, for example, documents, things that are documents or images. We were never really able to query that kind of data in the past very well. And then the other big one, which is related to that, is the ability to speak to the database, to ask questions of the database, to do operations using natural language. So up to now, you've had to know the language of database, which is called SQL. You had to learn that language to speak to databases and to be able to do operations on database. And very few people know that. It's a very esoteric language. So now, because of AI and the AI that we built, you can actually just ask questions in whatever your language is, English, French, Japanese, anything you want. And we use the AI to translate that question into SQL. So it's a little bit like a language translator, like we've seen, other companies have, where you can translate, let's say, Spanish to French or something like that, or English to German. Now we're translating English or whatever language to SQL. So you no longer have to learn SQL. So line of business people can just use databases like they were never able to before.
Yeah, turning the language of databases, which is strings, into the language of humans, which is kind of things. Um, I want to ask you about your data strategy. The theme of Larry's keynote was AI changes everything. We always talk in this industry about all the sexy things like energy, GPUs, CUDA, libraries, LLMs, algorithms. Sometimes people forget about the data. Obviously, you're a data person, and we're here talking about AI meets data. How do you describe your, AI for data strategy? How is it helping customers, get to AI faster? Because we all know you can't have good AI without good data.
Yeah, that's right. And so again, we're using AI throughout the product. So everything from loading data, a big part of it is asking questions to the database, ability to ask questions against documents, against images, searching for data, finding data, combining private data in the database with public data to answer questions. Again, this is something you were never able to do in databases before. So you can ask questions like, how is the growth of my product X compared to my competitors out in how they're growing? You can just ask that question just like that. And what we enable the LM to do is basically query the database, find out the sales of your products in the last few months, look at the growth, and then compare it to your competitors based on public data that it finds that you can find in the internet. So that kind of stuff was never possible before. So it brings entire possibilities that just couldn't happen before against data types that were never possible before. Things like documents and images, videos in the database, even things like genomic data, patterns, fraud, all sorts of things like that. And then the whole development of applications is dramatically different also. It's dramatically faster. So now you can create applications against your database in 10 times, 100 times faster. But a lot of what we're doing in that space is really focusing on enterprise development, because LMs are very good at generating code. You can describe an app and it'll generate thousands of lines of code for it. But then the question becomes, okay, I'm an enterprise. Can I use those thousands of lines of code? How do I know I can depend on it? How do I know it's going to be available? How do I know that it's not going to leak my private data out? So that's a lot of the kind of questions that we're focused on.
I want to ask you about what you're doing for devs, but before we do, I wonder if we could just double click on a couple of the capabilities inside of the AI database. Obviously, vector search for the early days of AI, Gen AI, people were going out and bolting on, if you will, a separate vector database. I want to understand what you guys have done with vector search, retrieval augmented generation. That's built in. Unified vector search. What are those things? How do they work? How are they integrated?
Yeah, so that's an interesting question. So vectors are kind of the key new data type that databases have that we never had before. So we've had in the past things like strings, numbers, dates, that kind of stuff as the data types in the database. Now we have this thing called a vector. And a vector represents the semantic content, kind of like the meaning of a document or an image or a video or a pattern of some sort in the data. And we can query across these things. So we can find similar images, we can find similar documents. So when you ask a question in natural language, we can match that up to a document or even an image. And using this vector search technology, which is very new technology. And that's been built into the Oracle database. And for businesses, the key thing is you need to be able to search based on that new AI technology, plus all the traditional business search technology that we've had for decades. So one of the things that we do that's very unique is we can combine these searches. So you can search for things that match, like how I'm like, for example, what kind of account do I have? Where do I live? What's my balance? All that kind of stuff. So you can combine those kind of queries with the AI queries to get a much better result, much faster. And the kind of things that you need. There's no point in telling, for example, a customer about an account that's not the kind of account that you have. So you need to be able to combine this information, or maybe you don't have a credit limit to buy something, so there's no point in offering you that. So it's that kind of thing that's very unique, and we go across all the data types. So that's a huge deal in the database world.
So what about What about devs, the development arm? I mean, people talk about vibe coding. You just mentioned, yeah, you can generate a bunch of lines of code, but how do you know you trust it? So, what specifically are you doing for the developers out there, and what have you announced?
Yeah. So again, this is a big area. I would say the biggest part of this is really what I call privacy. So when you allow the LM to see your data, how do you know it's not going to leak private data? So whether it's financial data, I can't see your bank account, you can't see my bank account. That's just guaranteed in traditional systems. I can't see your medical records, you can't see my medical records. That has to happen. And even whatever retail data, anything. So every consumer has privacy. I can't see your airline tickets. You can't see my airline tickets. And that has to happen. Now, when you turn AI loose, when you build apps with AI, how do you guarantee that this privacy is still maintained? And what we see is you can't really trust the AI to write the code that guarantees that. When the stakes are this high, like if you leak medical data, financial data, that's not just a mistake, that's a crime. You can get huge fines. You can actually go to jail for leaking medical data. So it has to be guaranteed. For enterprises, you have to guarantee that the data stays private. So now you have the AI generating the app. How's that going to work? And the answer is it's not. You really can't trust it. We all know that AI has things like hallucinations. It can make mistakes. It can misunderstand you. And so all that kind of thing has to move into the database. So one of the things that we've built is the fact that now the database understands who you are, David. So it knows, hey, this is you, this is your accounts. And when the AI queries the database, it only sees the data that you can see, that you're authorized to see. So it will see your account information or your medical information or your retail information. It will not see mine at all. So it can't leak data that it cannot see. So the database guarantees for each end user, the AI only sees the data that end user is allowed to see. So that's probably the biggest thing. So we move that down into the database that's traditionally implemented up in the application. But now because AI is generating the application and it generates it in minutes, just to validate and make sure that it could take weeks. So nobody wants that. So we're moving that kind of thing down. And it's the same thing with a lot of other business rules like data integrity, data locking, data validation, data evolvability. A lot of these things were kind of built into the app. And with the AI generating it, and you must guarantee it, it's much better to move those capabilities into the database where we can guarantee it underneath the AI.
Well, I think it's a super important point because, again, a lot of the media buzz is around, AGI and consumer AI, but really what you're talking about is unlocking that proprietary data and protecting that proprietary data inside organizations. Sometimes I like to call it enterprise AGI, sort of a play on words, but that's really where the real value is going to come for enterprises. And you guys, I love the AI factory. Jensen's obviously making a lot of good getting a lot of attention around that. You guys use the term AI private agent factory and select AI agent. So you're doing a lot in agents. You've announced a lot of agents. What are those items and how do they help customers get into AI?
Yeah, so that's an interesting point. So agents kind of the AI technology is constantly evolving, and agents are basically things, AI that does things. So up to now or up till recently, AI has been mostly about answering questions. So for example, for data, we hand it data and we hand it a question and we tell it, okay, here's your question. Here's the data that you're going to use. Give me the answer to that question. Now we're turning it around with agents. We're going to the AI and saying, here's a question and here's tools that you can use to access whatever data you want to answer that question. And so the AI is basically saying, okay, I'm going to reason about this. How do I answer this question? Well, I need this data from over here. I need that data from over there. I need to combine these two. I'm going to go to the public internet, get some more data, and I'm going to generate an answer. Or I'm going to take an action in the database. So agentic AI is really, the AI is actually the main actor. It is taking actions, not just answering questions. And I think of it as the AI is in the driver's seat. So instead of me telling it, okay, turn left, turn right, go straight, you just tell it, hey, take me there. And it decides, okay, the best way to get there is this route. So I got to do this, then I'm going to do this, then I'm going to do that. And it can adjust on the fly. It can say, well, this road is busy, so let's go that other way. It's the same thing with data. It's going to decide, oh, to answer this question, I can look around and say, well, what data do you have that can potentially answer this question? I can query that. I can query something else. I can query something else, and I can put the whole thing together.
Thank you for that. I want to ask you about quantum. You guys announced quantum resistant algorithms inside the database. I don't know what to make of quantum. It seems like it's getting more and more real. I don't know if the last mile of quantum is going to be like the last mile of, full self-driving. We'll see. But I'm curious as to how you can actually implement quantum resistant algorithms before quantum is fully here. Should customers be concerned about quantum computers? What's your sort of time horizon there?
Yeah, the time horizon is a little bit difficult to predict. So quantum computing has been advancing extremely rapidly. We were just at, what they call qubits, like, dozen qubits just a few years ago. Now we're in thousands, tens of thousands. It's advancing dramatically. And for databases, I mean, quantum is primarily a giant number cruncher. That's the way I think about it. It can crunch numbers faster than anything that's ever been invented before, like orders of magnitude, many million times faster. And the primary concern, databases aren't as much about number crunching. We're about data crunching. So the question is, well, why do you care? Well, we use encryption algorithms. That's how we keep data safe. That's how we keep the internet connection safe. And those encryption technologies are basically based on number crunching. That's how encryption is done. And so the risk for us is there's a quantum computer that's invented that can then crack the database. They can steal the data from the database or steal the data from the network, intercept data that's going across the network that's asking questions for the database. So that's been the concern, the primary concern on our part. And a lot of people have been thinking about how to make quantum safe cybersecurity, basically encryption algorithms. And so there's people around the world, the top scientists have been working on that problem for quite a number of years. And a lot of proposals have been made and they've been shot down and there's been a lot of evaluation. Now there's some new algorithms that we believe are quite quantum safe. And so what we've done in the Oracle AI database is we've implemented those algorithms both for data that's stored and for data where we communicate across the network to make it quantum safe. So if in a few years we have a quantum computer that can break this stuff, they won't be able to break these algorithms.
I want to ask you about autonomous AI Lakehouse. You guys announced that. And the big news there, of course, is you're embracing Apache Iceberg. I'd love for you to talk about that. And I think Databricks, I think, coined the term Lakehouse. I think you have included Databricks somehow in your autonomous AI Lakehouse announcement. How does this all fit together? And what's different about your autonomous AI Lakehouse versus everybody else's Lakehouse?
Yeah, so first of all, lakehouses are changing very dramatically right now. So what Lakehouse is really storing data in usually an object store, a common place where lots of people can access the data. Now, up to now, it's mostly been, storing the data where one product can access the data. Maybe other product can read it, but they can't write it. Only one person can write the data. And so what's come into the market recently is something called Apache Iceberg. And that defines a common format for storing data in object store that can be read or written. And that's the key new thing, is by many different vendors. So now it's kind of like a USB-C for data. You put the data out there in this format and everybody can read and write it. So that's a new technology that we've adopted in our AI database. And of course, we have all our AI technology and all the database technology that we've invested in for the last 50 years, which is very leading data warehouse and data lake technology. So that's the big new announcement, is we're bringing AI, we're bringing everything that we've done for the last 50 years to this new lakehouse technology, which is based on this industry standard format, such that any vendor can read or write the data. It's no longer locked to a specific vendor. It's available for all the different vendors across the ecosystem to access the data. It's kind of like I said, the USB-C for data.
Okay, and what about Databricks? I mean, Ali Ghodsi acquired Ryan Blue's company, Tabular, and they developed Iceberg, that format. And of course, you guys have jumping around here, but you also have the governance catalog of catalogs, so you're catalog agnostic. That was another super impressive piece of it. There's so much here, but what about Databricks? How do they fit into this?
Yeah, Databricks is one of the main vendors in the data lake space, and they are fully supporting this iceberg format, as is pretty much most of the major vendors in this space. Almost all the major vendors are supporting this in this space. So yeah, but Databricks, they bought the original company that invented this Apache Iceberg, but it is an open standard now. That's an Apache standard, which is open to everyone in the world. And so yeah, we're all basically, the entire industry is moving toward this. And what we're doing that's kind of unique is we're bringing all the technology that we built over the last almost 50 years. So everyone that's invested in Oracle and built applications on top of Oracle can now use that exact same SQL, all that stuff against an Iceberg data lake.
Okay, there's another big unlock I want to ask you about, which is multi-cloud. It's ironically, Oracle has, to me anyway, the strongest multi-cloud strategy in the business. I can get Exadata and real application clusters. I can get them in AWS, Azure, and Google, and Cloud@Customer. So you've essentially built this super cloud. What's your take on multi-cloud? What's the update there?
Yeah, the update is the vision is real now, right? So a couple of years ago, we started announcing these things. Now we have around 50 data centers with all our partners, Azure, Google, and most recently Amazon. We've gone production. We're now production on all these. We have hundreds of customers running on it. It's growing extremely rapidly. This is something that customers have been wanting for a lot of years. Now we've delivered it. We have all our technology running there, our premier technology, which you mentioned, Exadata is in rack and DataGuard. Everything that we built for our own cloud is now running in these other hyperscalers as well. And as you mentioned, we also run the exact same thing on premises. We run it in Cloud@Customer. We'll even bring a cloud data center into the customer's data center. So we are the most flexible cloud vendor in the world now.
The last question. I want you to sort of give me your perspective on the competitive landscape. I think that you at one point had said that you guys are going to be, serious in this game. You clearly are making the investments. How do you look at the competitive outlook, and where does Oracle sit in your mind?
Yeah, I think we're in very good competitive shape these days. We mentioned multi-cloud. That's a huge development. All this AI technology, we think we're leading in AI. We're introducing AI pretty much faster than anybody else out there, and integrating it throughout. The other thing is our AI runs on both analytic systems and on OLTP systems. It works across all the different data types. And we've had a lead in mission critical for decades, and we continue to do that. We continue to run most of the big important businesses in the world, and that makes it easy because they're already running Oracle. They can just drop our AI database, the new version in, and they get AI right where they are. They don't have to move data, they don't have to do anything. We've now expanded into Lakehouse in this open format, which has never existed before, bringing all our technologies there. So from pretty much every dimension you look at now, I think we're looking extremely strong from a competitive point of view.
And you pointed out, I mean, you said, I think it was you or Larry said, I'm surprised nobody else has really leaned into autonomous. I presume that's because it's not trivial to do, but I'll
Yeah,
give you the
building a mission critical autonomous database is actually a lot of work, and then building AI on top of it, and having it work for both, biggest banks, stock exchanges, and the biggest lake houses, that kind of thing, warehouses, is extremely difficult. That's something that's why we have over 5,000 engineers working on this for decades. It's a very hard problem. But what we do is we make it simple for customers because we architect the whole thing together.
Well, the innovation agenda is in full vision here at Oracle. Thanks, Juan, for spending some time with us. Really appreciate it.
Dave, it's always fun talking to you.
Okay, and thank you for watching this special CUBE conversation. I'm Dave Vellante. We'll see you next time on theCUBE.